Hi there guys, and welcome to preliminary chemistry and the first topic, chemical earth. Today we're going to be having a look at the spheres of the earth. So we've already started to have a little bit of a look at the particle model. Today I want to start to throw in some of the different ways in which we look at the chemistry of the earth. So the first thing we need to do is to identify the fact that the earth has four main spheres. And these four spheres are the biosphere, the lithosphere, the hydrosphere, and the atmosphere. Each of these are mixtures. And the mixtures are dominated by certain types of elements, and also those elements being combined in fixed ratio combinations to form compounds as well. So we're going to have a look at each of these spheres in detail. The first one's the biosphere. So the biosphere is the section of the Earth where life exists. So that's obviously going to be from within the crust through up until some levels of the lower atmosphere. It's dominated by organic molecules, and organic molecules tend to be based around carbon, hydrogen, and oxygen, okay, in varying ratios. Now, in things like proteins, you'll also have nitrogen, and you may have some sulfur. Fats are dominated again by carbon, hydrogen, and oxygen, and so are carbohydrates. And also nucleic acids, and they are the replicating building blocks of life. So when we're looking at the biosphere, we are looking at a part of the Earth that's dominated by carbon, hydrogen, and oxygen compounds. But we're also looking at a high portion of water. So this, of course, too, is a compound, and water is a very important component in most living organisms. There are also some additional elements and compounds in trace amounts, that is, very small amounts, and they include things like sodium and potassium, iron, and chlorine. The second section we want to look at is the lithosphere, the second sphere. The lithosphere, litho meaning rock, so this is the part of the Earth that is the solid section. It consists of the crust and the upper mantle. Here, the mixture, I guess if you like, is dominated by silicate compounds. So again, they're compounds, but they're based on silicates is silicon and oxygen. Okay, these form the framework or the backbone, just as in the biosphere we have carbon dominating. In the lithosphere we have silicon dominating. And if you have a look at the relative position of those two on the periodic table, then that kind of gives you an idea why we can use both of these as our frameworks, as our building blocks for complex molecules. The rules around silicate chemistry are much more complex than those around organic or carbon chemistry, and so we won't go into these in an awful lot of detail. Suffice it to say that as well as things like aluminium and iron, there are a number of different elements that can also be found in the lithosphere, but a very large portion of those are based around the silicates, silicon and oxygen. We know also there's trace amounts of things like gold and copper and silver and all sorts of things like that. The third sphere is the hydrosphere, and hydro means water, and so this is the sphere that is based around water, and that's both fresh and salt water. So we've had a question already around the oceans and the sodium and chloride ions that are present. You also have calcium ions, carbonate ions, a few other different elements and compounds, ions, that are present in both fresh water and also in the salt water, just in varying concentrations. We also know that a couple of gases like oxygen and carbon dioxide are capable of dissolving in water, and so therefore we would also find in both the fresh and salt water trace amounts of oxygen and carbon dioxide, and often they are related to temperature. The final sphere that we want to have a look at is the atmosphere. And the atmosphere is the gaseous layer above the surface of the Earth. And you'd be aware that it's basically a 4-to-1 ratio of nitrogen to oxygen, about 80% nitrogen to about 20% oxygen, approximately. And then there's a few trace amounts of argon, carbon dioxide, argon, neon, helium, and so on, hydrogen, all sorts of things. So there's a few little trace elements of other things there. We also know that there's a few pollutants that are also in our atmosphere, and they are also going to change the nature of the mixture. So each of these are very important spheres of the Earth. They are all mixtures, and they contain mixtures of either dominant elements or dominant compounds with traces of other substances as well. So here's a question for you. In which region of the Earth would you expect the compounds of carbon, hydrogen, and oxygen to dominate? Well, we've got four options. So we've got the lithosphere, we've got the hydrosphere, we've got the atmosphere, and we've also got the biosphere. The lithosphere tends to be dominated by the silicates, so silicon and oxygen. The hydrosphere is dominated by water, so hydrogen and oxygen. The atmosphere is dominated by nitrogen and oxygen. So it's the biosphere that's the one that's dominated by carbon, hydrogen, and oxygen. So in this case, the region of the Earth that we would expect to be dominated by compounds of carbon, hydrogen, and oxygen would be the biosphere. Thanks for listening.